5.3, deja vu. Double angle formula for sine. All we did really is just keep the angles exactly the same. We added the formula and voila, we have progressed in trigonometry. That is so awesome. For cosine, double angle formula for cosine, it turned out to be 3 different formulas. So the question is, which one do you use? It depends what you're given. So if you were given a ratio for sine only, I would use this one. If you're given a ratio for cosine only, I would just use this one. And this one, maybe used sometimes, maybe not, but if you want to, that's fine. All right, and then tangent, here's yours. If you can look up the addition formula for tangent, all yours. And then you just walk through those, check on homework. Issues, and you guys talked about any issues on 5.2. I know we covered it, but that's all good. Also, I am checking to see if you guys checked your work as well, right? So there should be some kind of indication, either check marks. Yeah, I'll set up. That's what we can. Yeah, like when you get something, you don't. Yeah. Okay. So. So do you want us to put little checks by them when we get them right? Because I haven't been doing that for. Say that again? Yeah. So you were just saying that you want us to put like little checks when they were right. So can you do that? Because I haven't been doing that with any of them. Yeah. Just to indicate to me that you have been checking your work. Like some people put actually how much they got correct, like 12.
So is it okay if, like, instead of putting checks for everyone, we just put dashes through one K-pop?
Yeah.
That'll be fine.
Yeah, when I get one, I do put like a dash through it and then.
Yeah, maybe on top. Minus 0.
Remember how I told you on question
anywhere at all?
Oh, I see. Yeah.
Do you want me to go through and do
And
all the
also,
previous
so that
ones?
question is,
Okay.
like all that applies.
Okay.
I also feel that.
Yeah, we normally do it together.
We do it together and so we're like, well.
You're also thunder and lightning. We forget that.
Oh, that's right.
Who's the doobity doo? Probably you. You seem like a doobity doo. Exactly.
All right, let's jam with it here. So tangent of A plus tangent of A, and you guys have to help me out here with the, look at all this good stuff here. I changed the setting of the computer, so does it look a little brighter? Or no? All right, awesome.
I can't see lights or anything.
Matthias, that's your problem at that point.
I'm sorry, I can only sense by echo. Yeah, you need that 8 lecture, like with like 8 layers.
Yeah. Sign of 2
Yeah, everybody's sitting there looking sculpted. Interpretive data. Yes.
We're gonna compose a classical music piece and communicate this information.
That is the most looking thing I've ever heard.
Yeah.
That's fun. Okay, are we good there?
Is there purposely no tangent?
Or a beluga
Oh,
whale?
I get it.
All right, Hayden, question?
Is there purposely no tangent means?
Correct, yeah. So this is the formula for the addition for tangent. So tangent of 2a, oh, I should have stuck it in here. So this is tangent of a plus a. So more like that, and then it goes to here. because we want to keep the a's exactly the same. And we want to see what happens here. So this would be the double angle formula for tangent. And I think I got a grand, so 2 tangent A.
Yeah.
On top, I got a 1 minus tan squared A. And we have just advanced trigonometry. There it is. So why is this important? Why is the sum formula kind of like more helpful? Or actually the double angle formula more helpful than the sum formula? Real quickly here. So how about if we get 15 degrees, that's pretty easy. 15 degrees is 45 degrees minus 30 degrees. Are we good? And so it seems like the double angle formula is not really helpful at all. Because if we take, except when we get to this spot right over here, if I take 15 degrees and I divide it by 2, I get, I think I get 7.5 degrees, something that I would not be able to get with the subtraction or addition of 2 angles. We good? How about 45 degrees? 45 degrees cut in half? $22.5. Again, another angle I would not be able to get at all if I'm just adding, subtracting angles. Good. So those are the 2 angles there. So let's get started. Exercise 1. Yeah, let's do proofs here. So prove. Let's do those, and then we'll start. Then we'll do the calculations here. So all yours this. And you guys know proofs already like crazy here. So I'm gonna give it to you, let you guys try it yourself. Go, have fun. 2 cosecant 2x is equal to tangent x plus cotangent x. Circle stuff. All right, let you guys get started here. I'm going to start just a little bit on my side. I guess I could change tangent and cotangent to other things here. So this would be sine x over cosine. Cosine over sine. You guess I'll get those in terms of sine and cosines. This one, I guess I do the same here. Let's see. This little 2 is a multiplier, right? So this will actually will stay on top. And I think that's what I have here on the bottom. Is that good? Sine of 2x? Anybody help me out?
2 sine x cosine.
Okay, this little sine 2x becomes 2 sine x cosine x, right? That's because of the identity that we just made. On the other side, I'm thinking maybe get common denominators. Maybe that might help. Let's see. Oh, so it's going to be cosine x times sine x. Each one of these guys coming down. Another cosine x sine x over here. What goes on top of the first fraction?
Or sine squared.
Yeah, it looks like I need a multiplier of sine x on both sides. So how about a sine x squared, sine squared x? This one needs a multiplier of cosine of x and another cosine of x. This becomes cosine squared x. Boom, talk to me some more. Ah, cool, white. I can start singing Jeopardy. Da 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 da. Something about twos and stuff like that. Twos cancel. We're good there. That guy and that guy should cancel easily. 1 over sine of x cosine x. That's cool. I like that one. And I think the rest we can kind of get to, right? So common denominators here would be, I like that denominator because those are exactly the same. Perfect. Pythagorean theorem right up here. And we are good. That one, same as this one. And I like check marks today. Nah, I like boxes today. Okay, good. Easy enough. Raise your hand if you got that before me. Okay, raise your hand if you had issues with it and like, I'm still not understanding proofs that well still. Okay.
Wait, you turned it into a 1 because, okay.
You're good. No problem. You guys ask the questions. Again, that's what we're here. If you already knew this stuff, you would not be here. You'd probably be in calculus.
Yeah.
In calculus. Okay.
Because we're all definitely like socialists right now.
Oh, yeah.
Right.
Yeah, definitely.
Okay, one more or another one here at least. Sine of 2, let's see, sine of 2a is equal to 2.
And we're proving this?
Uh-huh. I wonder if they change variables on you in the homework here. Let's see. Oh, theta. Sometimes they use theta. Yeah, they use a. Okay, cool. Dun, 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 dun. All right, let's practice some more with these just to sort of get used to these. I figure if we do 3 or 4 of these guys, we would be all right, let's try yourself here first. Go for it. You might have to think back. Let's see. Cotangent squared. Tiny bit of a tricky one here, but I'll let you guys think it through here. Give you some hints. Maybe think about 1 plus cotangent squared a. That might give you a little place to go. So what we'd do here, get rid of the double angle formula, because that's easy enough to do, and then sort of see how we can do the other things here. So on the left-hand side, 2 sine a cosine a, that's pretty simple. At that point, there's kind of not much you can simplify there at that point. So it looks like the right-hand side is what we're going to be kind of simplifying. If I change everything sines and cosines right now, oh man, that would not be fun. So I'm thinking, because I'm going to have complex fractions on my hands, right? Anybody 1 plus cotangent squared a? 1 plus cotangent squared a. Is it cosecant squared A? Okay, that might just help out a lot better here. So if I have this over,
So if you have that, then can you change this top to sines and cosines?
you can, At that point, maybe this is probably the time to do it. So this one's gonna be a weird one here. So the 2 has to be on top. This would be cosine over sine. We're good there. And cosecant is going to be 1 over sine squared A. Is that about right? Does that look about right? Okay, and then complex fraction, I know we can take care of that by changing it into a multiplication problem. So that now changes into this being taking the reciprocal. That's cool. I think I got where I wanted to with it. Let's see, the 2 stays, the sine and the sine squared reduce. So that goes away, that at least goes away, and I'm left with exactly what I wanted here. On this side, and I can bring this one all the way down as well, and voila. Are we good? Sorry, that was a bit of a toughie with the complex fraction here. 2 or 3 more of these guys here. Let's just gonna get some practice in. All right, tell me if you're done or if you need more time. See some people still writing that out, so cool. Okay. That might be a good one here. Cosine squared theta. All right, I'll let you guys try this one yourself. Get a little bit of time. I'm gonna stop the recording or pause the recording here. Let's go with it here.
I'm like so, you know someone's gonna get seriously,
Yeah.
but that's okay.
I'm
It's
sure
probably
we're
gonna be
gonna
error.
find angles.
Yeah, it's probably gonna be error. But I am so excited.
Gonna be on this.
And then next week we have line dancing. Like,
Oh, that's gonna be fun.
like this is just a good couple weeks. I am, I think we're back to home.
Minus cosine squared theta. Okay, so here's our choices right here. Can you guys read that? Is it okay? There's your 3 formulas for cosine. So I'm thinking don't use this one because that has sine in it. So either this one or this one. But this one also has sine in it. So I'm thinking maybe we'll just go with this. We'll see what happens here. So left-hand side exactly the same. Right-hand side just changed into 2 cosine squared theta minus 1 over 2. Are we good? How many, just out of raise your hands out of curiosity, how many use this one? How many use the bottom formula? No, okay. Still would have got to the same answer. That's no problem here. So yes, there it is. The ones, that one and that one, they're going to cancel themselves out. And you're like, oh, well, voila. 2's are gone. And I get exactly what I want on both sides. Are we good? Okay. What do you guys say? One more-ish, maybe? This one give you, how about this? I'm going to give you 2 double angle formulas inside here. So how about cotangent theta is equal to sine 2 theta 1 minus cosine 2 theta. That would be boom. Okay, all yours. Again, give you a little bit of time. I'm gonna pause the recording. Let you guys try it yourself. All right, you at-home students. Ha ha ha, we did the whole problem without recording it. So sorry about that, but you should be able to see it here. The flow as we're going to use this formula to plug into here. The rest is simplification as you go for it. I'm going to leave that at least there so you guys can see the work done. All right, exercise 5. Here we have if sine A is equal to 12 over 13 in quadrant 2, find, oh, sorry, not find sine of 2A. So let's think about just where we're at here. So this is a angle. We're trying to find sine of 2A. So I guess at the end, I need this right here, right? Sine of 2A. What I do have, what's given is sine of A. So I'm given a single angle formula for it. I want to double my angle. I have no clue what my angle is, but I want to double my angle, and then I want to know the sine ratio of it. And since we're in quadrant 2, let's kind of go off to the side here. Don't need to write this down here, but since we're in quadrant 2 right here, let's see, our angle measurement could be anywhere from like 91 degrees to 179 degrees. Is that right? So when I double this angle, let's see, 91 plus 91. So if I were to double and it was very, very close to like 90 degrees, it would double and go into quadrant 3. Good. If I were to double 179 degrees, that would flow into quadrant 4. So I know I'm going to end up in either one of these quadrants. Does that make sense? Since I'm just doubling my angle, it's going to flow into there. But as far as computation goes, here it is. I'm going to get sine of 2A is 2 times sine of A times cosine of A. That's cool. I have the 2. I have the sine value. I just need to know the cosine value. This one is just our formula for the doubling of sine.
Oh, okay.
Just wrote it down, and then I plugged in whatever I know so far. I know the 2. I know the sine A value, that's in quadrant 2. Still no cosine, so off to making ourselves a little drawing board here. So let's see. Since this is the y value, this is the r value. Looks like it's going to be a little triangle like this. The y value is 12, r value is 13. I need to know the x value. Oh, the -5 is perfect. Let me just do the work real quickly here. So this is y value is 12. We're going to square that guy. We're going to have a 13 squaring that guy. So how about 144, 169. Juice those, and we have a choice between a plus or a -5. That's our choice algebraically. Since we're in quadrant 2, we got to choose the -5. Are we good? So your choice is based upon which quadrant you're in. Okay, that's the case. I think I know what cosine is. Cosine is -5 over 13, and I got myself the value that I need. 60. Tell me if you guys agree there. -120. And from the sine
Oh, wait,
value,
so you already multiplied the two.
the 2 got multiplied with, let's see, I multiplied right here, that made 60.
Oh, okay.
And then I multiplied by another 2 in front to make 120 over 169. Are we good with that? Now, because the sine value, because the sign on the sine, I don't know which quadrant I'm in. I don't really care because I got the value for it anyways. We're good, but I understand that whenever I double something, it's going to go into the other quadrants. Let's do that, yeah. Okay, are we good with those? Just the computational ones. Notice the weird thing is we don't know what the angle is. We don't even care what the angle is. So we went from one ratio and we got another ratio. That's the whole issue here. All right, maybe a little easier one. If sine of A is equal to 3/5, find cosine of 2A. All right, so again, we have 3 different formulas to choose from. You guys talk to me here. Which formula do you guys want to choose? I'm thinking I'm going to go with -1 minus 2. That one right there. Cool. I want to choose that one because I just know what sine is. We good? If it said cosine A is equal to 3/5, I would choose the other one. And then do we use that formula for sine squared minus cosine squared? Hardly ever, because then you need to know 2 things for it. So why bother when you can just plug it in? So I think I just plugged this in. Let's see. And the question comes up with students is, Mr. Ng, why do we even do this? We're kind of going to like the weeds of something, isn't it? We're like proving formulas, proving identities, doing and so one of the things is chapter 5 gets us ready for chapter 6 for solving, but another one is just all the stuff we know already, identities, ratio values, just exploring it. Okay, you guys talk to me, make sure I don't do anything wrong here. Is that true? All that is good? And then common denominator would be 25 at that point. And final answer, how about a 7 over 25? Cool. And yeah, let's go one more. Exercise 7. Tell me if I'm going too fast here. Graph. Yep, the graph pieces here. Graph for me this little guy right here. All right, talk to me here. Which formula does it look like? It's like the double angle formula for cosine, huh? Cosine of 2a is equal to 1 minus 2 sine squared. Ooh, look at this. The 2a is over here, right? But the a is over here. So see if this makes sense. that this whole piece right here is the A value. Good there? So if that's true, then this piece becomes cosine of 2, bless you, of 2x. Tell me if you guys agree. Does that make sense?
Why do you get to assume that it's equal to cosine?
Because this is the formula, this is the double angle formula for cosine.
Yeah, but why do we get to just, or you're just saying that we can put it in because they're the same?
Yeah, go ahead, talk to me. See if,
Like the y is equal to cosine of 2a, like you can just do that?
eventually, yeah, we have to simplify it first. So we have, that's the problem. We have ourselves our equation that gives us the equivalency between the two. We good? And so if that's 2a, if that's a technically, right? Then we can plug it back into here. So we're going to make this formula here. So cosine of 4x is equal to, see if you guys agree here. Is that agreed upon now? Georgia, good, good. So now we can substitute. Once we have that in place, now we're going to go to here. And why did we do that in the first place is you can graph this guy or you can graph this guy. I think the latter one is a lot more simple, right? And so let's see if we can. This is just a cosine curve. And how fast is it going? How long does it take to do one period? Pi over 2. So amplitude is 1. That's easy enough. Period is 2 pi divided by 4, which becomes pi over 2. Karina was correct. All right, so we go over here, pi over 2. Ooh, take half of that. Now imagine 2 pi is like way over there, right? 2 pi is humongously over there. So what we did is we're going to scale our graph here. Pi over 2. Half of that would be pi over 4. Half of that would be pi over 8. Good. And then 3 pi over 8. So I'm thinking like pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Okay, Georgia, did I answer your question on it? Okay, just making sure. Boom, boom, and there it is. Cosine goes from here, goes to this point here, low point, back to 0, and then back to 1. That is so funny. So if you want to take the extra time, graph this on your calculator, see if it comes out to be exactly the same. You have squares in there, you have 2's in there, but then it turns out just to be a cosine curve anyways. All right, and I am done.